Thank you. Good afternoon, everyone. That's me, Peter Moore. I'd like to start by explaining a little bit about the fact that Amazon Web Services, which is who I represent, is a part of Amazon and something that started 11 years ago. How did Amazon become Amazon Web Services? Well, Amazon had a lot of technology requirements, and as such, they were looking at ways of very efficiently using their information technology. And as a result of that, they came out with some very unique characteristics, which we call web services, a service-oriented architecture in the way that we deliver IT, initially to the internal departments of Amazon, and then subsequently through Amazon Web Services to millions of customers around the world. So 11 years ago, Amazon Web Services started on March 14th, 2006. We launched the first service called Amazon S3, which is a simple storage service used for storing anything you like. And that was the beginning of Amazon Web Services. Since then, we've had this incredible pace of innovation. So in 2016, last year, over 1,017 to be exact, significant new features and services were released to market by Amazon Web Services. Incredible pace and incredible growth of innovation, and we'll have a lot more this year, of course. In fact, over the duration of that period up until 1st of January 2017, you'll see on the outside of this a list of some of the more significant features and services. In all, 2,913 significant new features and services introduced over that short 11-year period. We have global infrastructure, and this is important for any organization that wants to take their business global. So we have 16 global regions, 16 infrastructure regions around the world. Each of these infrastructure regions has 2 or more availability zones, and in all we've got 44. Each of these availability zones is independent of one another and is made up of multiple data centers. And in all, we have 101 edge locations, which are for caching and delivery of content, all the way to the edge of the network, making our performance very, very fast. We've got new regions announced in a number of countries as well. All in all, we have an incredibly rich set of programmable services, ranging from the core services at the bottom that you'd be familiar with from IT, like compute and storage and networking and the like, all the way through to analytics and development and mobile products and IoT and artificial intelligence there in the middle. On top of that, we have a range of applications available both from Amazon and from third parties, and a set of technical and business support to help people who want to take advantage of all of these services. So our model for delivery of IT is very different from the traditional model. We call it pay-as-you-go, which means that you only pay for what you use. You don't have any upfront capital investment. You pay per the gigabyte or per the millisecond of execution time, etc. And you have virtually unlimited capacity, means that, importantly, you don't have to plan ahead. You don't have to worry about how much compute, how much storage do I need next year, the year after, or in 10 years from now, because you're only paying for what you use. Unlimited capacity available to you. Turn it off at any time. So if you're not working on the weekends, you don't have to pay for it. You stop paying for it any time you don't need it. And we've lowered the price 62 times since we started in 2006, meaning that we're continuously looking for ways to drive down the cost of delivering these services and making them available to our customers. So far, we're doing pretty well. As of the third quarter of 2017, our year-on-year growth rate was 42%, which comes as a result of having over 1 million active customers every single month, and an annualized revenue run rate of $18 billion. So 42% growth is impressive, but particularly when you look at the fact that that's an $18 billion annualized run rate. We have the largest number of startup customers in the world using Amazon Web Services today. I would guess that a majority of mobile applications you're running on your phone today are running on Amazon Web Services. And you can look here for a list of many of the startups that you may have access to today are running on Amazon Web Services. Similarly, it's not just startups, it's also enterprise customers. So you'll see here a list of the biggest enterprise customers in the world, including companies from Korea like Samsung and LG and Docomo. There's companies from all around the region, companies from all around the world. And public sector is not left out either. So government, education, non-profit organisations around the world have taken that leap to moving off traditional infrastructure and leveraging Amazon Web Services because of all the benefits that I've just described to you. And Korea is also there. So here is a list of some of the startups and enterprises and public sector organisations in Korea that are already taking advantage of Amazon Web Services. So I just wanted to point out to all of you that there is over 1 million customers every day using Amazon Web Services, over 10,000 public sector customers around the world using Amazon Web Services every day, and you can see a very significant number of Korean customers as well. So if you're not already using Amazon Web Services, tomorrow would be a good time to start. But let's talk about artificial intelligence, because that's what this conference is all about, right? On AWS. So, believe it or not, it's not new for us. Back in 1995, we were using artificial intelligence on Amazon.com. So this is, again, for any of you who are around then that understood the internet, that's what the internet looked like in 1995, and this is Amazon.com books. And back then, we were making recommendations to people on what books they might like to read based on the previous preferences that they'd made. So 20 plus years now, we've been focused on how do we do that deep insight, how do we do that deep learning, how do we take that and make that available so that the end user experience is significantly enhanced from what it was prior to the advent of this capability. I want to give you an example of where we are today with shopping. And here is the Amazon Go shop, available as a prototype in Seattle. And this is the sort of store that you can just walk in, grab what you want and walk out. But rather than me telling the story, I have a short video to show you. That's meant to have sound. Can we have sound?
You could walk into a store, grab what you want, and just go. What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So we've come a long way in 20 years, and it's not only in the shopping experience. You can see here on the top left that we try to enhance the shopping experience for everyone through our artificial intelligence and deep learning. We have a robotics company that is going to one day deliver products to your front door called Amazon Prime Air, and that's using artificial intelligence and deep learning to map the world and make sure that it doesn't run into things and that it's safe. Bottom left corner you can see the Amazon Alexa Dot, which is a device that you can talk to and it will talk to you. Amazon Go in the middle, and then on the bottom right side you can see our Kiva product, which is a robot that we use in many of our fulfillment centers that's used to do that hard work of going and picking the goods from the shelf and taking it to the place where they're going to put it in a box and send it to you, making it very, very cost effective and efficient. So all of these areas we're using deep learning and artificial intelligence, and these form the basis of the experience that we've had over the last 20 years to now bring that capability to all of you as well. So let me talk about 3 key capabilities on artificial intelligence powered services. Amazon Rekognition is an image recognition and analysis powered by deep learning. Amazon Polly is text-to-speech powered by deep learning, and Amazon Lex allows you to build natural conversational interactions in voice and text. Let me talk about each one of these. So Polly, Rekognition, and Lex are the AI-enabled managed API services that are available for anyone to use from our cloud. It provides a usability and simplicity that make these types of complex capabilities extremely easy to program to and make available as part of your application. That sits on top of our deep learning frameworks, and we have a wide range of frameworks available from MXNet to TensorFlow, Theano, CAF, and Torch. These are all do-it-yourself deep learning models for custom models, so allowing you to build up the learning that's necessary for the artificial intelligence that you're going to make available in your application. Lifelike speech coming from Polly is truly lifelike. It converts text to lifelike speech. It doesn't sound like a robot, it sounds like a person. It's a fully managed service, meaning you don't have to worry about the underlying infrastructure that you need to run that program. You don't need to worry about the compute or the storage. It supports 47 different voices from around the world in 24 languages and has very low latency. It's real time. Even though you're going to be using a device and going to the cloud and back again, it's in real time. You don't have to wait before you talk to the device. So things like accurate text processing, intelligible, easy to understand, semantic meaning to text, and customized pronunciation allow you to do things like articles and blogs and training material and chatbots and public announcements, all using this capability. Rekognition, the image analysis piece, over 1.2 trillion photos will be taken in 2017. That's an incredible lot of photos. So what should we do about that? Well, I think it's important to have some image recognition capabilities to allow that massive amount of photos to be easier to manage. So Amazon Rekognition is that deep learning-based image recognition service, allows you to search, verify, and organize millions of images. There's 4 capabilities. The first is object and scene detection, so you can tell what's in a photo. Facial analysis, so you can make some analysis of the face you're actually looking at. Do a comparison between 2 faces and determine is it the same person. And facial recognition, which allows you to choose from a known face from a range of faces that you can see and find the person you're looking for. All of that's based on the core services of Amazon Web Services, and you can build out that. In this example, you can see the photo where Rekognition has automatically detected all of these elements within the photo. It searches, filters, and curates image libraries. It has smart search so that you can produce user-generated content for each of your images. And it's very, very useful in areas like photo, travel, real estate, vacation rental applications. When you come to facial analysis, it will locate faces within images, and it will analyze the facial attributes to detect emotion, pose, facial landmarks, and features. In this case, you can see there's 97.4% chance that this person is a male, even though they have long hair. But he's happy, he's smiling, has a moustache, 100% guaranteed that's a moustache, and he's got a beard, 65%. And the eyes are open. So this is very useful if you're trying to do sentiment analysis of photos. You want to capture user demographics. You want to even improve online dating matches, dynamic and personalized ads. All very useful capabilities. Face comparison. How about the opportunity to measure the likelihood that faces in 2 different images are the same person? In this case, you can see there's a color photo and there's an old black and white photo, and it was able to detect with 97% guarantee that this is actually the same person. In the case of facial recognition, it identifies people in images by finding the closest match for an input face image. So you choose one input face image, and it will look against a collection of stored face vectors to determine any match. You can see along all of these faces that all look quite different, it's chosen the ones that match that input face image at the top there. Very useful. In fact, I've got an example of how that can be used. In Washington County, the Sheriff's Office looked at using this capability for public safety. They were able to index more than 300,000 photo records within 1 to 2 days, and the identification time of suspects went down from between 2 and 3 days down to minutes. Within 1 week of going live with this capability, the solution built on recognition identified a suspect that was a cold case and led to an arrest through due process. So a fantastic outcome, something that is obviously very useful for public safety. How about autonomous driving? I know there's been a lot of conversations about autonomous driving today, and there'll be a lot more. And I wanted to sort of share with you that autonomous driving uses a lot of deep learning, artificial intelligence, and these capabilities from Amazon Web Services are very useful in meeting some of those needs. To give you an example, here's a video of a autonomous driving system. You can see the cars driving along here are a different coloured box to the person walking across the road. This is obviously in Beijing, where walking across the road is quite dangerous, but you can see the cars and the buses and the bicycles all meandering around the street, and how quickly the recognition is able to pick this up. Not only that, but it's actually identifying the make and model of that car. So it knows every car, what model of car it is. It knows if it's a bicycle, if it's a person. That's pretty impressive in an environment where there's a lot of sunlight and colour and you can pick out the different contrast. But it even works at night time. So you can see on the right side now that this is at night time. It's monochrome because it's at night. And you can still see how quickly it picks up moving cars. Even though it can only see the headlights coming in the distance, you'll see how quickly it identifies that as a moving car. This sort of thing is really important when you talk about public safety, when you're talking about driving safety. It's very important if we're truly going to move to an autonomous mode that we can have access to these cost-effective deep learning systems and artificial intelligence to integrate in with our systems. So here we saw object identification and recognition, those deep learning models that actually create the models of the road, the navigation, the relevant objects, and the driving direction decisions. You can see in the center, the green is the identification of the road, and edge computing in the vehicle itself allows for real-time decisions to be made in vehicle when you need that microsecond response. And then on the right-hand side, you can see the centimetre accurate positioning that comes also from that edge computing to allow you to be really, really precise when it comes to avoiding objects that are on the road. Another example I wanted to give you actually started off in Indonesia as a IoT, Internet of Things project, where a professor from Wollongong University in Australia tried to address the challenge where Jakarta, the capital of Indonesia, is sinking. Urbanisation and groundwater use have meant that the city has sunk significantly from 1976 through to 2004, as you can see from this NASA image. So the effect is that every year the capital floods, and this is the effect, where there's significant water damage and loss of life every year because of this flooding, and no one really knew how to address this. So this professor actually built these fairly cost-effective devices which simply were put under the bridge and could sense the water levels in all the streams and rivers flowing into town. He collected all of that data and created a big data lake, added to that the data from the city about the flooding and when it happened and where it happened, added to that the topography, added to that the weather information, and did deep learning on all of that, and then was able to very accurately predict when the floods would occur and how damaging they would be. So this now gives early warning to people that it's going to flood, and they can put their goods up high and they can avoid certain parts of town. Now, that's something, but what he did was when he was installing these devices, here he is on the bridge installing one under the beam, he thought to himself, well, maybe I can use this new artificial intelligence capability from Amazon Web Services called recognition. And if all the waterways that flood, I put a camera on there and I use recognition to identify is there a vehicle or a person involved, then I can save lives. So this is now called flood scene recognition, where Amazon Recognition automatically flags things of interest, such as people or people in vehicles that are affected by flooding, and can automatically send off to emergency services a notification that someone's in trouble, and people can go and rescue that person or that people in the car in the flood. So a tremendous added advantage of artificial intelligence and deep learning to actually apply to something that was already being deployed across Indonesia. So Lex, which is the last piece, is the conversational image. Maybe some of you in the room were around when we did punch cards and memory registers. I was. The second generation is computers as we know today, which is pointers and sliders. And the third generation is conversational interfaces. So Amazon Lex actually has features of text and speech language understanding, which are powered by the same technology that powers Alexa, the device that's available from Amazon. You can talk to it, you can say, I want to do some shopping, I want to turn the lights on or off, I want to know a recipe, I want to know how many ounces are in a kilogram of butter or whatever. And it will talk to you just like a real person using those Lex capabilities. You can use it in chat services to replace a call center, so you can actually have people getting common information without waiting for a person in queue. And it's designed for people who want to build things. Enterprise SaaS connectors are available for some of the big CRM products like Salesforce and the like to allow you to interface this with those capabilities. So as I said, information bots, application bots, enterprise productivity bots, and Internet of Things bots, allowing you to do news updates, weather information, book tickets, order food, check sales numbers, wearables, appliances, auto, etc. So many of the car manufacturers are now installing Lex into the cars so that you're not distracted while you're driving, and you can ask the car to do things for you, like call John or tell me where the nearest pizza shop is or anything you want. NASA are actually using it with ROV, which is the latest Mars rover, to demonstrate the capabilities of voice interaction. So they're taking this around to schools and colleges, and they're showing students what the next generation of conversational interface will be like by telling ROV what to do. And it's actually far more effective to say ROV go left, ROV stop, rather than trying to type that into a keyboard while you're interacting with the device. It's even better than using a joystick. I want to wrap up very quickly on artificial intelligence for security, because without security, all of these things become a bit scary. And so artificial intelligence for security can be achieved through what we call Amazon Macy, which is a new service, a machine learning powered security service to discover, classify, and protect sensitive data. The first thing it does is it gives you visibility into the classification of all your data by screening all your data and determining what is classified, what is personally identifiable, what has phone numbers in it, and it classifies it for you using artificial intelligence. Once you've done that, then you can look at user behavior and you can find out who is accessing confidential information, who is moving confidential information, and so it helps to identify risky or suspicious activities. And then you can have automatic alert categories which allow you to be alerted, provide early warning on security compliance issues as it relates to people accessing the data. So in conclusion, there's more AI built on AWS than anywhere else. So there's never been a better time to build. The AWS pace of innovation, the new capabilities that are available daily, mean that it's a fantastic opportunity for everyone in Korea to start using these capabilities to build into your products, which you can export around the world. Thank you.
Thank you very much. 예, 감사합니다.